Hello everyone, welcome to VKJ Maths Academy. Today I am going to explain you about ways of number representations. This is the topic which is sometimes mistaken by children. Okay, here I will discuss about 5 types of number representations. First one is decimal places, standard forms, rounded to nearest numbers, significant figures, upper and lower bounds. Let's start with decimal places. Sometimes in a mathematical calculation, we generate a bigger number. For example, 15.75 into 10.55 produces 166.1625. Based on the importance of the number, the 4 digits after the decimal may not be required. For a simpler representation, it may be asked to write the number up to 2 decimal places. In this case, we would need to discard anything after this. The point to note here is that the digit after 2 decimal places is 2, which is less than 5. Therefore, the carryover value to the previous digit is 0. Finally, the number up to 2 decimal places can be written as 166.16. If the same number, that is 166.1625, was asked to write up to 1 decimal place, in that case, everything after 1 has to be discarded. However, the first digit to be discarded is 6, which is more than or equal to 5. In this case, when the whole digits are discarded, it will carry over a value of +1 to the previous number. Altogether, the newly formatted number would be written as 166.2. Let's talk about the next topic, the standard forms. Standard form is also called as scientific notation. It is a way of representing a big or a small number retaining its significant information. A number in the standard form is written as x point y into 10 raised power z, where x is an integer whose value lies between 1 and 9. Y is the remaining part of the number, whereas z is an appropriate index. Let's illustrate this concept with some practical examples. Example 1. Distance between Moon and Earth is 384,400 kilometers. In standard form, this would be represented as 3.844 into 10 raised power 5 kilometers. Here, the first digit is an integer between 1 and 9, then the remaining part of the number, then multiple of 10 with an appropriate index 5. The index value 5 comes from moving the decimal 5 places to the left. Let's look into another example where mass of a grain of sugar is 0.000625 grams. This number in the standard form can be written as 6.25 into 10 raised power minus 4. Here the first digit is an integer between 1 and 9. The remaining part of the number comes here after the decimal, multiplied with 10, having an appropriate index of minus 4. The index of minus 4 comes from moving the decimal 4 places to the right. Let's talk about third type of number representation, which is rounded to a nearest number. Rounding to a nearest number is well explained on a number line. Here, the nearest number means the minimum measurable number on the number line. Let's understand this concept with some examples. First example, where I want to write a number 456,789 to its nearest hundreds. Since it is asked to write this number to its nearest hundreds, the scale to represent this number will have minimum denomination of 100 only. Here in this example, the first number could be 456,600, 456,700, and 456,800. The number to be represented on this scale may fall somewhere here. Since it is after midline between two numbers, this number would be represented by the next number, that is 456,800. Let's take another example where I want to represent a number 1.23 to its nearest tens place. Since it is up to tens place, the minimum marking on the number line would be up to tens place only. Here in this example, it could be 1.1, 1.2 and 1.3 like that. Now 1.23 may fall somewhere here. Since it is left of the midline, this number would be represented by the closest number, which is 1.2 in this case. Let's take another example where I have a measuring jug which can measure volume in liters. So this is the measuring jug and it has got minimum measurement unit of a quarter liter only. So something like this. It can measure up to 1 quarter, half liter, 3 quarters and 1 liter. Suppose I have a volume of 0.55 liter to be measured in this jug. The jug will fill somewhere up to here. The closest measurement on this jug would be half liter. This jug measures to the nearest quarter liter and in this case the measured value is half liter. Let's look into the fourth type of number representation, which is called significant figures. Significant figures are another way of rounding the numbers where we want to draw attention to non-zero highest value numbers. For an example, suppose we have a number 456,780 and we want to round it to 3 significant figures. In this case, the first 3 non-zero highest value numbers are 4, 5 and 6, and anything after this needs to be rounded. Since the next digit is 7, which is greater than or equal to 5, in this case it will round up the previous number by +1. And the new number becomes 457,000. Let's look into another example where we have a number 0.045678. Let's round it to two significant figures. In this case, the first two non-zero highest value numbers are 4 and 5. Since we want to round it to two significant figures, anything after this needs to be rounded. Since the first rounding number is greater than or equal to 5, while rounding, it will carry over a value of +1 to the previous number. And finally, the number rounded to two significant figures becomes 0.046. Let's take another example where we have a number 20.367 and we want to round it to four significant figures. In this case, the first four non-zero highest value numbers are 2, 0, 3, and 6. One has to pay attention that 0 is counted here as it lies between two non-zero digits 2 and 3. Now any number after four figures needs to be discarded. In this case, since the number to be rounded is greater than or equal to 5, therefore it will carry a value of +1 to the previous number. Finally, the number rounded to four significant figures becomes 20.37. Now let's look into the final topic, which is upper and lower bounds. Upper and lower bounds are the errors generated due to earlier rounding methods. Let's take an example where we rounded a number to two significant figures and that number was 0.045. Since this number 0.045 was rounded, it would have been greater than or equal to 0.0445 and less than 0.0455. Here, this is the lower bound and this is the upper bound of the rounded number. Let's take another example where we rounded a number to two decimal places and the number is 10.56. This number would have been originally greater than or equal to 10.555 and less than 10.565. Now in this case, this one is the lower bound and this one is the upper bound of the rounded number. Here I will stop the discussion on the number representations. Look into another video clips for some more interesting topics from VKJ Maths Academy. Thank you.